So when we move from outer space to our Earth, the first thing that we encounter is actually the magnetosphere, but what you see in this image is our atmosphere. Believe it or not, between the moon and the atmosphere, there is a sphere of magnetism. It's out there even though magnetism is invisible. We can detect it. Matter of fact, if you have iron filings, they'll actually align themselves with the magnetic flow lines. Remind me next time, and I'll get out my magnet and my iron filings, and I'll show you a magnetic field. It's invisible. It's a force field, but you can see how it impacts, how it arranges the iron filings. Well, supposedly our Earth has a magnetic field too. You see the sun in the distance? There are particles that shoot out of the sun, little charged particles called ions. What's that referred to? What is that? The solar winds. And so as the solar winds hit our magnetic field, they distort it. If you need to be thankful for something in your prayer, thank Him for the magnetic field and thank Him for the atmosphere. Because if we took away our magnetic field, the magnetosphere, and we took away the atmosphere, we would all just die of radiation poisoning from the solar winds that would cause us all to get cancer and radiate us. But the magnetic field deflects much of the radiation, and our atmosphere absorbs much of the radiation, which allows us to live a nice, comfortable existence here on Earth. The atmosphere and magnetosphere are sort of like blankets, protective blankets. The sun produces what are called solar winds. They're particles that shoot out of the sun in all directions like small bullets. And whenever they hit our magnetosphere, the magnetic field around the Earth, it actually deforms. The energy comes out of the South Pole, loops around and goes back into the North Pole. That's the reason when you have a compass, the needle points north. Whenever the solar winds are ejected from the sun, they impinge upon the magnetic field, and you can see how they're deforming it downstream. This is good that we have it because it protects the Earth from the intense solar winds. However, when you have a large solar flare, some of the ions that come from the sun's interior, they're deflected around the Earth due to the Van Allen radiation belts and magnetic field. But you can see there's a small portion here that's captured and carried toward the Earth. And whenever these ions hit the Earth's upper atmosphere, it causes it to glow. And that glowing in the upper atmosphere is what we know as the Northern Lights or the Aurora Borealis, which means the Northern Lights. However, the same thing happens in the South Pole. See here? And when those ions are pulled toward the Earth and they impinge upon the upper atmosphere in the South Pole, they're called the Aurora Australis, or the Southern Lights. So we have this halo around the Earth not only at the North Pole but also at the South Pole. This is a weather image of the United States, and that glare that you see here is the Northern Lights. And you see how far it extends, right, into the northern tier states? If you live in Minnesota, Michigan, you may have seen the Northern Lights. If you live in Canada, you certainly will. There was a sunspot max. Sunspot activity increases and decreases. What was it, about 6 years ago, 7 years ago? There was a sunspot max, and there were several large flares that were occurring. And when you have flares, that's producing a tremendous burst of energy coming from the sun. And the Aurora Borealis was seen in Oklahoma. There are parts of Oklahoma that were seeing the Northern Lights because that radiation actually began to spread like chocolate down an ice cream cone, began to flow down all the way to Oklahoma. Of course, that sunspot activity is gone now, so they've retreated back into the northern tier states. This is a photograph of the Northern Lights from the space shuttle. You can see the light is in the upper atmosphere. It's what they call the ionosphere or the thermosphere, and that's where they occur. And you can see them dancing in that area of the atmosphere, but they don't come all the way to the Earth because of that blanket air. Here's another image of the Aurora Borealis from space. In this one you can see the two distinct colors, red and green. The red is where the ions interact with nitrogen and the green is where they interact mainly with oxygen. So the colors come from different concentrations of the gas. This is Aurora Borealis from the ground looking up, and again the red is the nitrogen, the green is the oxygen. But you can see the relationship there from space, and this is what it looks like from the ground. What you're seeing are static images. If you were actually observing the Aurora Borealis, they would flow, they move across the sky like curtains blowing in the wind. Do you see a constellation there? Yeah, the Big Dipper. So these two stars point toward, a line drawn through those two stars point toward the North Star, polar. The people that lived in the Nordic regions in Sweden and Norway, they blended into their myths, and so the red was the blood of the gods, and the movement is war that's going on in the heavens, because that was part of their theology, right? Norse theology. Whenever you die as a Norse warrior, where you're going? To heaven, what do they call it? Valhalla. It's like the big mead house in the sky where you sit with your fellow warriors. Not reminiscing, this is one thing people miss, not reminiscing about the battles you fought on earth, but waiting for the great battle that was to come, because you're a warrior, so there's got to be a great battle at the end when the gods will actually destroy everything in warfare. So it's a whole theology developed for warfare. So the blood raining down from the sky and the northern lights, that's something that fit into their mythology. It may have even motivated some of their mythology. But anyway, northern lights. When you get near the polar regions, it's almost like you're looking up into the lights. You can see here.
At the southern end of our planet, fiery ribbons are illuminating the winter skies, the Aurora Australis. This light brings no warmth to the male penguins, who are still huddling, defying the coldest conditions on the planet. Their ordeal is drawing to a close.